Hello and welcome to Group 11's Memory Management Animation. A drinks manufacturing company has recently seen an increase in bottled drink sales, encouraging them to produce more beverages. Currently, the process of packing drinks bottles into boxes has been done manually by staff at the factory. However, this method will no longer be suitable for the company given the increase in drinks production. The drinks manufacturing company therefore want to implement an automated system for placing bottles into their respective boxes to be transported. They are unsure of what type of system to implement in their factory as they produce two different types of drinks bottles, plastic and glass. An appropriate solution is to use Next Fit and Worst Fit. For Next Fit, the plastic bottles are allocated into the next suitable box, meaning the box that is big enough or bigger that can accommodate the bottles. For the first set of 6 plastic bottles, the machine will find the suitable box, which is either a box with 6 slots or 8 slots. In this case, the machine will put the bottles into the box with 6 slots because it arrives first on the conveyor belt. Once the machine detects that the current box with 6 slots is suitable, the bottles will be inserted into it. Next, the second set of 4 plastic bottles arrives at the machine, and based on the first set's results, the next current box is the box with 8 slots. The machine will be able to detect that this box is suitable to contain these 4 bottles and will insert them into the box. For Next Fit allocation, the search always starts at the last hole allocated. Similarly to First Fit, Next Fit allocates to the first hole that is large enough. The advantage of Next Fit allocation is that it's a fast searching algorithm and avoids memory allocation always from the beginning of the memory space. The disadvantage is that it tends to waste memory. Our earlier example is a good way to visualize memory allocation, with the conveyor belts acting as memory, the boxes as partitions, and bottles as processors. In the case of Worst Fit, the glass bottles are allocated into a box with the largest available space. In other words, the process is allocated into a partition with the largest available space. This is because the Worst Fit algorithm allows processors to search through the entire memory and find a partition with the widest available space. As seen in the example here, a set of 6 glass bottles have arrived at the machine. The machine then determines that the boxes with 4 slots and 6 slots are not suitable and skips over them to insert the bottles into the largest box, which has 8 slots. After inserting the bottles into the box, it will then be moved into the store and a second set of bottles can be brought into the machine. Now, a second set of 4 glass bottles have arrived at the machine. The machine will search through the entire belt again. After conducting its search, the machine will then move the boxes until the desired box reaches the front of the conveyor belt. Then, the machine will insert the glass bottles into said box. In this case, the box with 6 slots as shown in this example. Worst Fit allocation allows the processors to traverse the entire memory and search for the largest hole or partition that is available. This brings its own advantages and disadvantages. The advantage of Worst Fit allocation is that there will be large internal fragmentation. However, the disadvantage is that it's a slow process as they would have to check the entire memory before making an allocation. As we can see in this example, the first process goes through the entire memory until it finds an available slot, in this case partition 6. Then, the second process goes through the memory again until it finds its available slot, which is partition 4. To sum up, both Next Fit and Worst Fit have their pros and cons. In the case of Next Fit, it's a fast searching algorithm, but it wastes memory. For Worst Fit, it has large internal fragmentation, but it is a slow process. Thank you.